Hello students, today we are going to start topic differentiation. This differentiation is also called as the derivative of a given function. You have already studied the basic concept of differentiation or derivative, the 11th standard. Now, first we'll start with the representation of derivative of a given function. If any function, there are different types of function: algebraic, trigonometric, exponential, logarithmic, inverse function. Okay, so for any given function, suppose if we represent that function by f of x, therefore for any function f of x, its derivative is given by d dx of f of x is always equal to f dash of x. What? Derivative of any function f of x is always equal to f dash of x. Also, we can express this f of x, or we consider the value of f of x as y, or in the form of y. If we represent a given function f of x using y, okay, it is also possible to take or differentiate this function which is represented by y. If we take the differentiation or derivative of this both sides, left hand side as well as right hand side, so ddx of left hand side is equal to ddx of right hand side, gives dy by dx is equal to f dash of x. So derivative of any function, if given by f dash of x, it is also represented by dy by dx. The meaning of both is same. There is another representation of derivative of a given function. We know if function is represented by y is equal to f of x, its derivative is given by dy by dx. Sometime or in some cases, okay, this dy by dx can be represented as either y dash or y dash. Okay, so there are the different types of representation of derivative of given function. These are said to be the representation. Yeah. Now, before going to start with differentiation, the most important thing is that you must know all the formulas of derivative. Okay. Once you know all the formulas, it is very simple to find the derivative of given function. So we go for the quick revision of such formulas. Okay. Now the formula 1, important formulas related to important formulas for differentiation. Formula number 1. ddx of x to the power n can be expressed as nx to the power n minus 1. This x to the power n is known as the algebraic function, and its derivative n is any rational number. So its derivative is always given by this n x to the power n minus 1. To explain this formula, we take so many different examples how to find the derivative of given. This is a given function which is known as algebraic function, and as explained, we can consider the given function by y is equal to x to the power n. Okay, this is a given function, and suppose we have to find the derivative of this given function. we can express this by taking the derivative with respect to x of this left hand side as well as right hand side. We know the derivative of y with respect to x can be expressed as dy by dx, and this is right hand side, okay, that is x to the power n. According to this form, we can write nx to the power n minus 1. Here, this is not such a good example, this is for the form. Now, example number 1. If value of y is given x to the power, suppose 10, then derivative of this term y is equal to derivative of this RHS, that is x to the power 10, can be expressed by writing dy by dx in the left hand side is equal to, according to this formula, x to the power n. If you compare both, n is 10, so we apply this formula, and x to the power n minus 1 means right here 10x to the power 10 minus 1, that is 10x to the power 9. In such a way, we are able to find the derivative of any given. One more example. If value of y is given in the form of, suppose, like this 3 by 2, it is a fraction. The power is in fraction. We are also able to apply the same formula to find the derivative of such function. Therefore, we apply the derivative with respect to x of left hand side as well as right hand side. Now, using the same relation, that is formula, we are able to find the derivative of this function, that is dy by dx is equal to, here the value of n is 3 by 2, so we write here n x to the power n minus 1 form, that is 3 by 2 dot x to the power 3 by 2 minus 1, that is equal to 3 by 2 dot x to the power 1 by, in such a way that we are able to find the derivative of different functions. Now, in third example, suppose if power contains any constant, okay, x to the power any constant number. Let us consider that constant as k. Let constant is equal to k. So we can write y is equal to x to the power k. Okay. So we take the derivative of such k using the formula, that is ddx of left hand side is equal to ddx of x to the power k. That we obtain dy by dx is equal to kx to the power k minus 1. So whatever given in the power of x, we use this formula to obtain the derivative of given function. Now, this is the first formula. Next one, formula number ddx of a to the power x can be expressed as a to the power x dot log of a. Now, this a to the power x is called as the exponential function. To find the derivative of exponential function, this can be expressed a to the power x as it is with the log of this. So we take some example how to find the derivative. If given function is represented by y is equal to, suppose any number is given 2, its power is suppose x, then its derivative can be taken as first left hand side and then right hand side. We apply this formula over here is in the right hand side. Derivative of y with respect to y is dy by dx, and using this formula we can express a as 2b. Okay? So 2 raised to the power x dot log of. So whatever be the value of a is given, we can apply or express using this formula, or we can find the derivative of any exponential function. Now, next one, formula number 3. Third, derivative of e to the power x, it is fixed. E to the power x is always e to the power x. Formula number. Fourth one, derivative of log x. This is the logarithmic function, always taken as 1 by x. Here, derivative of log x is always 1 by x. You must have to remember all these formulas, otherwise it is not possible to solve the questions. Yeah. Next, fifth form is derivative of any constant number. Derivative of any constant is always 0. For this, we take some examples. Suppose we have to take the derivative of any constant case value is 0. Okay, is any constant. Right here is any constant. So derivative of any constant is always 0. Now, next one. Suppose if we have to find the derivative of some trigonometric function. Suppose we have to find the derivative of some trigonometric function. Now in this case, you know about the trigonometric ratios. There are 6 trigonometric ratios: sin, cos, tan, cot, sec. It is possible to take out the derivative of all the 6 trigonometric ratios one by one to discuss. Derivative of sin x, this is the standard formula. It is always cos x. Seventh one, derivative of cos x is always taken as minus sin x. Eighth one, derivative of tan x is taken as sec square x. Next form, 9. Derivative of cot x is always taken as minus cosec square. 10th one, derivative of sec x is always taken as sec x tan x. 11. Derivative of cosec x is always taken as minus cosec x cot x. So these are the derivatives of all trigonometric functions. That is called as the trigonometric ratios. Okay, these are very important formulas. You have to remember all these. Now we discuss some more formulas based on inverse trigonometric function. So for this, first we take derivative of sine inverse of x is always equal to 1 upon root of 1 minus x square. Next one, ddx of cos inverse of x is written as 1 minus x square. Next one, ddx of tan inverse of x is written as 1 upon 1 plus x square Next, ddx of cot x, cot inverse of x can be expressed as 1 minus 1 upon 1 plus x. Next one, ddx of sec inverse of x can be expressed as 1 upon x root of x square minus 1, and the last is ddx of cosec inverse of x can be expressed as minus 1 upon x root of x square minus 1. Yeah. So these are very important formulas. Once you know all these formulas, then differentiation is very easy for you. Now, some more rules regarding this differentiation. Okay. So we are going to discuss some rule that is called as product rule, and the second one is called as quotient. This is just like a revision type. Later on, we will go through exercise and some solid science. Now, rules for differentiation. Rule number 1. If given function is represented by y and it is the product of two functions represented by u and v, and suppose we have to find the product of two functions using differentiation. Therefore, this rule is called as product rule. Okay, how can we take the product of two functions using derivative? So, first we differentiate this given function with respect to x. ddx of left hand side is equal to ddx of right hand side. So it is nothing but dy by dx is equal to. Now, multiplication of two functions is given. First one is u, second one is v. According to the product rule, we write this first function as it is into derivative of second function plus second function as it is into derivative of first function with respect to x. This is called as product rule. Again, I repeat, if product of two functions is given, suppose we have to find the derivative of product of two functions, that we apply the product rule which is given by first function as it is into derivative of second plus second function as it is into derivative of first, which is called as product. Second rule is called as quotient rule. Quotient rule. Quotient is division. If any function is given by, it is represented by y, u by v. Okay, u divided by v. Suppose we have to find the derivative of this u divided by v. Then we apply the quotient rule, which can be expressed like this. First, we take the derivative of both sides, that is ddx of left hand side is equal to ddx of right hand side, that is u upon. So right here, dy by dx is equal to, now while applying the quotient rule, first we keep this denominator as is, this v as it is, into derivative of numerator, that is u. denominator as it is into derivative of numerator minus numerator as it is into derivative of denominator and whole divided by denominator square. Again I repeat how to find the derivative using quotient rule. If two functions represented by u and v given in numerator and denominator, like in the form of fraction, suppose if we have to find the derivative of such two functions, it is given in the form of fraction. So we apply the quotient rule, means first denominator as it is into derivative of numerator minus numerator as it is into derivative of denominator whole divided by v square. Now, to explain this product and quotient rule, first we take some example based on this product rule as well as quotient rule. So we start with product rule first. If question is if y is equal to x into log x, if y is equal to x into log x, then find value of dy by dx. This is the question. Now check the question. Two functions are given, algebraic, logarithmic, but both are in multiplication form. If both the functions are in multiplication form, then we use product rule to find the value of dy by dx. First we take derivative of left hand side with respect to x, that is ddx of y, and then ddx of right hand side, that is x into log x. Okay. We know that ddx of y always expressed in the form of dy by dx. Now, this is the first function. Suppose we consider u, and this is the second function. Suppose v. We know derivative of u into v can be expressed first as it is into derivative of second plus second as it is into derivative of first. So in the same way, we can express first term, that is x as it is into derivative of second function, okay, plus second function as it is into derivative of first function. Now here is the question. Here we are going to apply that rules which I already explained, how to apply rules or formulas to find the derivative. Now these two underlying terms are very important. ddx of log x, this is the formula to find the derivative of log x. We apply the formula for derivative of log x. We know derivative of log x is 1 by x. Now log x as it is, ddx of x, it is 1. How ddx of x is 1? First the right answer, this to cancel. This is the value of dy by dx. Okay. Now, why the value of x is 1? So I explain using formula as ddx of x can be expressed as ddx of x to the power 1 form. X to the power 1. That is equal to 1x to the power 1 minus 1. That is equal to 1x to the power 0. That is equal to 1. And any number raised to the power 0 is always 1. In such a way, we are able to find the derivative. Whatever be the power is given, power of x, we use that is x to the power n form, okay, to find the variable. Now one more question. Suppose if the same two functions are given in the form of fraction, if y is equal to log x upon x or x upon log x, whatever. Okay. This is the numerator. Suppose we represent this numerator by u and denominator by. And the question is find dy by x. Find the value of dy by x. Again we apply. Now we apply the quotient tool to find the derivative of this y is equal to log x by x. We know the quotient rule is if y is equal to u by v, then its derivative can be given by denominator as it is into derivative of numerator minus numerator as it is into derivative of denominator by v square. Yeah. Now, this is numerator, this is denominator. By quotient rule, first we take the derivative of left hand side as well as right hand side with respect to x. Now, its value is nothing but dy by dx, that is equal to. According to the quotient rule, we apply this rule to this RHS. This is your v and this is your v. So according to this rule, denominator as it is into ddx of